Hey everyone! So, in the AI world, we get really excited about the brilliant models, the mind-bending algorithms, right? But today, we're going to focus on the one phase that literally makes or breaks every single AI project. And it's the one that often gets the least amount of love: data preparation. So let's get into it and pull back the curtain on the process that really determines if you succeed or fail.
Now, look at this. This isn't just a friendly piece of advice. Think of it as a hard stop, a critical checkpoint you absolutely cannot skip. The source material for this explainer puts it this bluntly for a reason. Without a rock-solid plan for your data, everything that comes after is basically built on a foundation of sand. It's a non-negotiable rule.
So why is this such a big deal? Well, it all boils down to one of the oldest sayings in computing, which has become the absolute golden rule of AI. Garbage in, garbage out. You see, raw data, the fuel for our models, is almost never ready to use right out of the box. It's messy, it's incomplete, and honestly, it's often the single biggest risk to any AI project.
That's a pretty harsh truth, isn't it? I mean, you can have the most sophisticated model on the planet, the most powerful computers, the absolute brightest minds on your team, but if you feed that system flawed, noisy, or just plain irrelevant data, your results are going to be just as flawed. So that leads us to the most important question of all. How do we fix the garbage before it ever gets in?
Okay, so the transformation from messy, raw data into a powerful asset really stands on three core pillars. We're talking about data cleansing, data labeling, and data augmentation. Just think of these as the three essential steps you take to refine your raw material into high-grade fuel for your AI engine.
First up, we've got cleansing. This is step one, the absolute foundation. It's all about finding and fixing the problems in your data. We're talking about dealing with the corrupt stuff, the inaccurate entries, and all that just plain irrelevant information that's cluttering up your dataset and can totally poison your results.
And this brings us to the first critical question every single AI team has to answer. What's your strategy here? Are you going to just remove the bad data? Are you going to try to fix it or fill in the gaps? How you answer this is going to determine the integrity of your entire project.
And check this out. This is a fantastic real-world example of cleansing in action. So NASA was trying to predict aircraft engine failures. They had data streaming in from 21 different sensors. But it turned out some of that data was just noise. It was actually hurting their predictions. So they systematically went through and just removed the data from 6 of those sensors. And what happened? Their predictions actually got better. It's a perfect illustration that more data isn't always better, cleaner data is.
All right, so once your data is clean, the next step is to give it some meaning. And that brings us to our second pillar, data labeling. If cleansing is about, cleaning the data, then labeling is about teaching the model what it's supposed to be looking for. In supervised learning, you might show the machine thousands of pictures and say, this is a cat, this is a dog. That simple tag, that label, is the ground truth. It's literally what the machine learns to recognize.
And it's not as simple as it sounds. It's a whole process. It starts with collecting the right data, then deciding on the specific labels, which often involves having actual humans do the tagging. And then, and this is so important, you have to do quality assurance to make sure those labels are accurate and consistent.
If you want to see this human-in-the-loop thing on an industrial scale, just look at Coca-Cola. I mean, think about it. They needed to find their brand content pretty much anywhere on the internet. The solution? They actually employed people to sift through countless images and apply that Coca-Cola label. This created a gigantic, high-quality data set that they could then use to train a model to find it automatically.
But what happens if you don't have enough data to start with? This is a super common problem, and that's where our third pillar comes in: data augmentation. This is really just a collection of clever tricks to artificially expand your dataset. If you only have one picture of a cat, you can flip it, you can rotate it, you can change the lighting, and boom, all of a sudden you have 5, 10, maybe even more training examples from that one single image.
So this is the strategic question you really have to ask yourself. It's not just about the data you have. It's about what you need. How can you enrich what you've got to cover more scenarios? How can you make your model more robust and truly ready for the chaos of the real world?
Now, doing all this stuff once is hard enough, but for any real AI application, you have to do it over and over again, continuously. And that means you have to shift your thinking from just doing one-off tasks to building a fully automated system, basically a data factory.
Yeah, the best way to picture this is as a data assembly line. Raw, messy data goes in one end, and it moves through these automated stations for cleansing, then for labeling, and then for augmentation. And what comes out the other side is perfectly prepared, model-ready data. This whole system, this is what we call a data pipeline.
And there are some ground rules for building that assembly line. First, you have to build it before you even think about starting to train your model. And it has to be tailored to the specific needs of your model. One size does not fit all. And really important, it's not a set it and forget it kind of thing. You have to manage and maintain it over time, because your data sources and your needs are going to change.
Okay, so building these pipelines can get pretty complex. But the good news is we have new tools that can help. But, and this is a big but, with these new shortcuts come new responsibilities and some safeguards that are absolutely critical to get right.
Let's talk for a second about generative AI. I mean, the promise here is huge. It can help summarize data, it can fill in missing values, it can even pre-label entire data sets for you, which could save an incredible amount of time. But the danger is just as real. It can also subtly manipulate data, it can hallucinate facts that just aren't there, and it can amplify any existing biases in your data. It's an incredibly powerful tool, but you have to use it with extreme caution, and always with a human in the loop.
And speaking of safeguards, we absolutely cannot forget about privacy and security. This stuff has to be baked in from day one. You have to comply with laws like GDPR, you have to anonymize personal information wherever you can, you should only store the absolute minimum data you need, and you have to secure everything, the data, the models, the configurations, from being tampered with. This isn't optional, it's a requirement.
All of which brings us to our final checkpoint. Before you get to dive into the really exciting world of model training, you have to stop and make a very clear go/no-go decision. Are you really ready? Hey, remember that warning from the very beginning? Well, it applies here more than ever. If you can't confidently answer the next few questions, then moving forward is pretty much a guaranteed path to project failure. The key here is to be brutally honest with yourself and your team. So, first question, do you have a concrete step-by-step plan? Not just a vague idea, but a detailed, written-down procedure for exactly what needs to happen to your data. Is it a yes or a no?
Second, what about when things go wrong? Because they will. Is your plan for handling missing values and incorrect data solid enough? Have you actually tested it to see if it works?
And finally, the big one. Have you actually built that automated assembly line? Is there a repeatable, scalable data pipeline that's ready to go not just for the initial training, but for when your model is live, making real-time decisions on brand new data? That's the inference stage, and it needs the same pristine data as the training stage.
If you can say yes to all of those, then seriously, congratulations. You have successfully navigated the most critical phase of AI. Your data is clean, it's labeled, and it's ready. But this leads to one final, more provocative question. After all this work to prepare your data to find the truth, is your organization actually ready to hear what it has to say? Thanks for watching.